Welcome back. Lesson 16, where we add the next layer to our hardening stack, AppArmor. So far, we've covered firewall, log-driven response, and the kernel itself. Now, we move down to the process level. The mental shift here is simple but important. Unix permissions ask who owns the file. That's discretionary access control. AppArmor asks what a process is allowed to do, regardless of who's running it. So even a compromised Nginx stays confined by its profile. Let's make that distinction concrete. DAC is the classic Unix model. Chmod, chown, file owner decides. It works until a process gets compromised and escalates to root. At that point, DAC hands the attacker everything root can read, including etc. shadow. Mac closes that gap. The kernel enforces a per-process profile that holds even if the process becomes root, even if DAC would have said yes. On Linux, you've got two main implementation, AppArmor, path-based, Debian's default since 10, and Linux, label-based, the Red Hat world. We're on Debian, so AppArmor it is. Keep the mental model close. DAC is who, Mac is what, and stacked together they contain the blast radius. So what does an AppArmor profile actually look like? Every profile lives in AppArmors, one file per executable, and it's structured as 3 declarations: which capabilities the process can hold, which network sockets it can open, and which file paths it can touch, with what access. Notice the shape here. Net bind service to grab a low port, Situid to drop privileges, and nothing else. Network is constrained to IPv4 and IPv6 TCP streams. No UDP, no raw sockets. File access is explicit and path-based. Read its own binary, read its config, write its log, read-write its data dir, and an explicit deny on shadow that overrides anything any include might have permitted. Everything not listed is denied by default. That's the whole point. Now, a profile doesn't just exist. It runs in one of 3 modes, and picking the right one is how you roll AppArmor out without taking the app down. Enforce blocks and logs, that's your production goal. Complain logs the denial, but still allows the action. Think of it as a one-way mirror. You watch the app behave normally for a week and harvest exactly what it needs. Disable shelves the profile entirely, which is your emergency valve when something breaks at 3 in the morning. The rollout path is almost always the same. AA complain, observe, tune, then AI enforce. So let's walk that rollout end to end. Step 1, you generate a skeleton. aa-genprof if you want the interactive Q&A. aa-prof if you'd rather start from a clean template. Step 2, load it with AppArmor parser and drop it into complain mode. Step 3 is the patient part. Run the app through a real workload. Full test suite, a day of peak traffic, the cron jobs, the edge cases. Step 4, aa-logprof reads the audit log and walks you through each denial, asking allow, deny, or new rule. And only then, step 5, AA enforce, and AA status confirms the app is confined for real. Once a profile is live, daily operations get quiet, and that's the goal. AA status is your first check. It tells you the module is up, how many profiles are loaded, and crucially, how many are in enforce versus complain. When something breaks, the answer almost always lives in the kernel log. Grep journal sile for AppArmor, and you'll find lines like this one: denied, operation open, the profile that tripped, the path it wanted, and the requested mask. Read left to right. This binary tried to read that file, and the kernel said no. That's the whole vocabulary. Reload edits atomically with AppArmor parser umchar or system.ctl reload. AppArmor when you've touched the whole directory. Once you can read denials, you can write profiles. So let's look at 4 shapes that cover most of what you'll actually deploy. A web server needs to bind privileged ports, read its document root, and append to logs, nothing else. And shadow is explicitly denied as a tripwire. A database gets read-write lock on its data directory and a single TCP socket. A backup job reads source, writes to the mount, and execs restick with ix, so the child inherits this profile rather than escaping it. And the sandbox pattern, for batch workers that should never phone home, denies network outright, plus the capabilities an attacker would reach for first. Same grammar every time. Explicit allow, explicit deny, abstractions for the Libus plumbing underneath. A common misconception: containers don't bypass AppArmor, they run inside it. Docker ships a profile called Docker default and applies it automatically. You can verify by reading proc self enter current from inside any container and seeing Docker default enforce staring back. To swap in something tighter, load your profile with a AppArmor parser, then pass it via security opt AppArmor. The flag is identical for Docker and Podman. Kubernetes wires the same mechanism through the pod's security context, pointing at a local host profile already loaded on the node. Now, what we've covered today is AppArmor for host processes, with just a taste of how it extends into containers. If you want the full container hardening picture, that's a separate course in its own right. 13 lessons that walk from threat modeling and image scanning through rootless runtimes and capability dropping into per-service seccomp and AppArmor profiles, and finally, network policies, runtime detection with Falco, and Kubernetes forensics. Think of it as the natural sequel, same mental model, applied at container scale. Before we close, let's talk about the 5 places AppArmor actually bites you in production. Number 1 is the big one: shipping a brand new profile straight to enforce mode. The size log fills with denied lines. Uploads stop working and you're paged at midnight. The discipline is non-negotiable. Profile, complain, 24 hours under real workload, aa-logprof to tune, then enforce. Skip the complain phase and you will pay for it. The other 4, forgetting abstractions, base, forgetting to reload after edit, crude path mismatches, and the temptation to globally disable when something feels too restrictive. Each one is a lesson someone learned the hard way, so you don't have to. So here's lesson 16 in 6 lines. DAC answers who, Mac answers what. Stack them and a compromised process has nowhere to run. Profiles are paths, capabilities, network rules, and abstractions, with RWWALXM flags doing the fine-grained work. 3 modes: complain, enforce, disable. And the safe rollout always goes genprof, complain, 24 hours of real traffic, logprof, then enforce. Daily drill is AA status, journal CDEL piped through grep AppArmor, and AppArmor parser -er after every edit, and the same profiles plug straight into Docker and Kubernetes. Next up, lesson 17 closes stage 03 with the operational side, unattended upgrades and CVE response. Lesson 16 complete. The mental model is yours. The profiles are written. You've walked the complain to enforce path, and containers are covered. That closes the kernel and confinement arc. Lesson 17 wraps stage 03 with unattended upgrades and CVE response, the operational discipline that keeps everything you've hardened actually current. See you there.